Thank you for joining us, everybody. I'm Max. I'm a developer advocate at Fused, and I'm joined with Majid and Emma. And I'll pass it to you guys to introduce yourselves. Majid, do you want to get started?
Yes, absolutely. Hi, everyone. My name is Majid Olivan. I am a geospatial expert with 20 plus years of experience in the industry and academia, and excited to be part of this presentation and share some of our experiences with this amazing platform.
Nice. I'm Emma. I work with Majid. I'm also a geospatial analyst, lots of experience in the industry, did my master's in it, and worked for startups and consulting companies. So, yeah, excited to be here.
Yeah, thank you both. This is going to be cool. We're going to go through a few things. We're going to have just a bit of context here. Emma has a nice presentation for us, and then we'll have a few Q&A. But I want to start really high level at first. You guys said you have a lot of experience. Can you talk a little bit about like overall, what are some of the problems that you guys are solving?
Absolutely. I would say that from the beginning of my career in geospatial industry, I always heard this term: spatial is special and needs to be treated differently. And as we know, one of the reasons is the size of the data, the abundance of the data, especially in the past few years, which creates a lot of new applications and areas. Problems are becoming a lot more complicated. Environmental, transportation, all of those need a better kind of tools, platforms to process, analyze, visualize geospatial data, and integration with a lot of other data sources, which potentially most of them are non-geospatial. Integrating these kind of capabilities into a broader vision to solve a bigger problem it's always been a challenge, and there has been a lot of new improvement step by step within the industry, academia, and open source community, which takes us to this place that we are currently developing a lot of new applications, trying to solve a lot more complex problems. Good examples that will walk you through some of the kind of details in this session is like environmental analysis. We know that climate change is one of the key topics these days, a lot of concerns around it, for example, and having access to a lot of data sets uh, raises these questions: how can we use these data? How can we generate insights for decision makers? And similarly, across a lot of other industries, they're heavily related and needed to use geospatial data sets. And more importantly, how to make value for decision makers using these kind of technologies. So, a variety of applications. I would say that most of the industries these days they can benefit from these kind of capabilities. And happy to go a little bit deeper on few of them at the end of the presentation as well.
Can you give me a few words about how Fused fits into all of this and how it's helping you guys?
Absolutely. So, as I mentioned, the challenges of the geospatial data analysis, processing, and visualization was something that wasn't a simple task to be resolved. A lot of companies from Esri, you can imagine, they started doing improvements since 10, 15 years ago. A lot of other players like Carto, QGIS from open source community, you will see a lot of new advances from tech companies, AWS, Azure, all of those. They're trying. They have made a lot of improvement, but there has been still huge amount of gaps to bring all of these testing, development, visualization into one single platform. We'll see a lot of platforms make advances in visualization, for example, but they have a lot of gaps in backend processing. Similarly, with some of the new technologies, you will see that, all right, processing has been resolved, but it's hard to integrate it into broader pipeline because you don't have that kind of capability to build, test, visualize at the same time. And Fuse was one of, well, to me is the only potential platform that put us all together in one
Mhm.
environment. Quite advanced technology per my experience, and yeah, looking forward to explore more on what Fuse can do as well. So far, it was one of the technologies that I've seen beats a lot of other similar technologies in the industry.
That sounds cool. Thanks for sharing that. I think then the best way to show this is to have like a live demo of this. So Emma, could you take it away and show us what you have?
Yes, let me start sharing my screen. Awesome. So, like Majid said, we're always looking to explore different ways we can process data faster. How can we handle the large data sets? And Fuse gave us this opportunity to explore how we can pull in all these different environmental data sets and explore, in this case, a case study looking at vineyard irrigation patterns using raster hexagonification. So basically with this problem statement, we're just working with a couple of data sets, trying to analyze differences in vineyards across some grape growing regions in California and some other states, specifically looking, how are we seeing irrigation pop up, precipitation patterns, temperature, soil types that go into growing this from an environmental perspective. So this notebook is going to go through just a technical review of how we put those rasters into hexagons, and really leverage the H3 system. It lets us, it makes it a lot smaller and easier to store. You can partition things, query it super quickly, and then actually visualize these large spatial data sets. So in one place we can develop, visualize, and then have apps, which is really cool. So jumping into it, the key data sets we're using are the 2018 crop data layer from the USDA. So it's just a nationwide view for the grapes. I picked that year. It was a good year for grapes. Thought it would be the most interesting. We've also pulled in an irrigation raster from 2017 because it was the most recent one. And then also we have GridMET data for precipitation and temperature. So we can look at some of the weather and patterns, and then also some soil information as well. So the notebook is just going to tackle a few high-level research questions that we can get to from start to end, like do arid, warmer areas require more irrigation, and how might this vary across different states? And at the end, we have our Parquet files of these data sets. We're going to have some Fuse UDFs that we can load into Workbench to help us interact and interrogate the data set if we want to actually visualize it, not just in this notebook. And then just a few visuals and charts so we can see some of the trends happening. So it's all super easy. In the notebook, install Fuse, you have your credentials. I already popped in my credentials, and I'm just going to run this now so we can see how fast everything is. So let me re-credential quickly. Perfect.
How you know it's a real demo.
I know. This was not ran beforehand. This is all running live, and we have the credentials. I'm good to go. We've loaded in our Fuse notebook extension. So one of the cool parts about Fuse are their UDFs, the user-defined functions. And so these can be like helper functions like we're about to see. It's functions to help process the data, visualize the data, and we can just load a bunch of them together like you'll see in this demo to help us do everything. So this is just a utility UDF, just helping us read some of the spatial hex data from S3 that we've stored in there. We can filter it, do some basic area statistics per cell. And then it's also, when we go into Workbench later, you can see how it's supporting, when you zoom in and out, there'll be different adjustments on the hex level. So we're not looking at a super, super small hex that's very fine and choking our browser. Instead, we have more coarser ones. So that's kind of what's under the hood here with all the code. I won't go too into it just for the sake of the demo, but all of our functions are doing that. And then you can also set up the kind of the metadata for the visualizations when we pull them into Workbench. So we have our H3 set up. We have it set up so the colors are filled. It's pickable. It's going to be a continuous magenta scale when we actually load it up into Workbench. We save the metadata. And then as simple as this can write it to Fuse as a UDF, and we can grab the URL, click on and see the UDF you just grabbed. I won't do that right now, but we'll see them shortly. So that's just our helper functions, but then we get into the meat of the actual like data processing. So some of the layers are more complicated than others. The cropland data layer, it's pretty straightforward. What we want to get the value that equals grapes, so we can have all the grapes and aggregate them at a hex level from the 30-meter raster that they're at. So then we can actually do stuff with them. And we're just getting some basic statistics around area, percent area. And then we can run our UDF here. So I can actually even change this. I was playing around, like if we type in our crop type of like water, we have open water or watermelons because they both have water in the term. So it's actually running the UDF even as I do this within the notebook that we had just defined. So you can call it within here and run it. And similar as before, we'll do this a bunch, write the metadata, and then write our hex CDL over to Fused as a UDF. So the irrigation is also a pretty straightforward data set. It's basically a binary raster of not irrigated versus irrigated. Not a ton of processing needs to happen beyond getting it at that hex level, so it's easy to process. So we do that, metadata, write it to Fused. The soil data is a little more complicated. It's a nationwide view at 30-meter resolution. The raster essentially has values for map unit keys that we join in this UDF onto a tabular component table, so we can get the more interesting attributes of the soil, like the type, the drainage, percent composition, and all that good stuff. So this is actually reading it in, figuring it out what the dominant map unit key is per hex, and then attributing all the component tables for that, and helping, you'll see later, make all these nice colors so we can see a good map and visualize what's happening everywhere. And then our final data set is the GridMET data set, where we have our contiguous USA climate variables. So there's a lot of different climate variables in here. We've pulled in minimum temperature, maximum temperature, and precipitation. And this is a pretty large data set because it's available on a daily scale. So it's pretty comprehensive, and we're able to process it really quickly here, pull it into the hexes, do things like calculate frost days, or we can calculate the minimum temperature, the means, as well as the sum and median for precipitation. So we can get all those key climate variables that we need. And yeah, we put it up into Fuse, and now we have all of our UDFs for our 4 different data sets that we're going to be using. So we have all 4 of them, but they're kind of disparate. They're not joined yet. They're just all doing their own things. So this final UDF is going to help us combine them all together so we can start doing analysis, visualizations, and start to answer some of our research questions like, do areas irrigate more, comparing the patterns, etc. So we can define an AOI for our UDFs. I just chose Napa County in California. And then this UDF is going and joining the data. So if I scroll down here, you can actually see in this get data function, we're calling all of those UDFs we just created. So now they're being used to read that in. We have the data for all these data sets. And now that we have them joined, we can start aggregating at like the county level, so we can begin to make more sense of all the data that's happening here. So we have that. We have our joined data set. This is what it looks like when we run the UDF. We have our counties, the geometry, and you can see in one data frame here, we have soil, irrigation, the climate variables. So it's now in one easy spot. We can start doing charts, analysis, visualization super easily just by putting it into one UDF. So getting to some high level kind of comparisons of the data we actually have, looking at the question, okay, let's compare grape irrigation area and precipitation by county. So looking at it, we have a map of California, our study area. These are where all of the grapes from the crop data layer are happening. The gray indicates there wasn't any, and the darker purple means there's just more irrigation where there are grapes. So this central part of California is where we're really seeing that. And then up here as well. when we move over, mapping out now precipitation, where the higher values mean more precipitation and the lower values are less, it kind of follows an opposite trend where this central region isn't is a little more dry. So it actually does kind of track from a high level that these irrigated areas are more dry, just comparing it visually from county to county. And if we wanted to plot this out on like a scatter plot and see precipitation or temperature, there's a pretty rough correlation we're seeing here where as precipitation increases, irrigation decreases, which tracks you'd want to irrigate the drier areas. And then there's a reverse relationship happening here, where in the warmer areas, we actually are seeing there's more irrigation. So it does confirm an hypothesis that these drier, warmer areas are irrigating more. But if we wanted to take this to another state, for example, we can take the UDF we just had, and I switch out the state code for California, for New York, and say, I want everything the same, but I just want to see how this looks in New York. And I can run it. It just runs in a few seconds. And I see a similar map, but now for New York, where we're having high irrigation here. Can definitely see there's a lot less grape activity in New York. That makes sense. Not as renowned as California. And it roughly tracks where less precipitation happening, where we are seeing the irrigation, but not strong as a trend. And when I scroll down to the scatter plots as well, seeing similar stuff, not as strong trends and everything. So yeah, this is just the notebook, just showing how we can call this into Python pretty easily, visualize it, and do some high-level analysis and charts. And I'll jump over to the workbench where we can actually see all of those UDFs we were writing are getting written into the workbench, into my account. I can add them just by hitting add UDF and load them up into here. So I'll just quickly pop through the ones we're seeing. So for example, this is that CDL one, the crop data layer we were looking at. And I have this UDF, and now I can visualize it super easily. So if I wanted to change my study to, we were looking at watermelons, I can just hit this, it will run and show me where all these areas are, where there's watermelons, for example, in here. So I'll just take a few seconds. And then you can see the watermelons are here, much smaller area, not as big of a crop here. I'll put this back to grapes. We can
just to hear on that, the note of like, even if what you were showing in the notebook is still not running in your notebook, it's running infused, and what we're seeing here is just the same thing. All of it basically in real time. That's why you're able to switch crops in real time.
Yeah. And yeah, so all of these you can, like Max was saying, just do in real time, edit it. These are up here. We can see like irrigation that we were doing, the darker or the lighter areas where there's more irrigation, like we saw in our county map. This is, I'm going to zoom in a little bit. This is our soil data set, where actually when I zoom in, you can see some of the functionality for.
Emma, can I ask you to make your screen a little bit bigger, please? I'm getting that it's maybe a bit small for people.
There we go. Let me. Is that better? Looking at the map bigger?
Yeah, I think if that might be, or if you can like zoom in on the in the application, but otherwise I think that should be good.
Okay, awesome. Hopefully this is close enough for people to see, but you can see when we zoom in, we'll get different resolutions, like it was set up now at 8. And this is that helper function I was mentioning. We zoom in a little more, we get a change to 9. So it's not like when you're zoomed out, you just need a high level view. So this is cool. And you can just kind of get a trend for it as you zoom in. We have our weather data as well. This is just colored by precipitation. And then the cool one that we have that joins everything together is this join data set that we're pulling in our 4 different, weather, soil, irrigation, crops. It's just running. And right now it's centered on California. Give it a few seconds to run. Like we said, it's a live demo, so you can see all this stuff running in real time.
Yeah, we're pulling like a lot of data as well, like because we're doing this for the entire state.
It's a large state, and these are massive data sets, 30-meter resolution for the contiguous US. So it's able to do it really quickly. we're able to get this county view we were looking at. It's just colored by precipitation right now. If maybe the hexes aren't exactly what you wanted. If you did want to see hexes, this is where you can start updating your UDFs, and it can just interactively change while you're like doing your data exploration. And it's going to update now into hexes resolution 6. In a few seconds, there we go. You can see how it changes from county into hexes just with these changes. And yeah, so that's kind of our case study and how we were able to use it to do all of our raster hexagonification.
I've got a few questions I want to ask you about this to dive into it a bit more. So you took multiple different data sets, and then we're bringing them all in together, and then you're joining them. Why work on hexagons and not on the original data sets, which are rasters? What's the value there?
Mm-hmm. I think like we were mentioning before, we just find the H3 system super, super easy to use. It's a nice standardized system. We're able to save it very easily as parquets, do partitionings, really take advantage of reading it in quickly. We have the whole indexing system. I also really like it because it's supported in a lot of like SQL languages, so it's very easy for me to use. And because it's universal, it just transfers very nicely across different platforms, or if I'm reading it in. So those are some of the advantages I've seen.
Yeah. And then we talked about notebooks, we talked about Workbench. They're two different ways of interacting and writing code and interacting with it. What's the value that you're seeing in there in using either notebooks or Workbench and using them together?
Yeah, I mean, so in a lot of my work, I love using notebooks for like developing. I like checking things out while I'm working. It's just a nice sense check. But I've always kind of struggled a bit. Like I write my code, then I pull into QGIS or ArcGIS, I visualize it, then I have to go back and make changes. So I think this is really helpful where I'm able to write my UDFs and visualize things on the fly. So I can actually see what's happening. Like Majid mentioned, like the spatial is very important, especially in the geospatial field. So much of it revolves around that. So that's where I found it. It's like a nice combination of notebooks and the visual platform all in one that make it easy to develop in.
I think one element that we can highlight here as well is when you're doing these edits or when you're doing these joins, we're not saving the files directly. So what you're mentioning here before of like going into QGIS or ArcGIS is you probably have to write a file somewhere. Say, okay, here's my file, and then in ArcGIS I'm going to go open it, and then I go back to my notebook, I go again, I make an underscore v2 of my file, and then I open it again, and I have these different layers here. You're not writing a file, it's executing in real time, so you're able to see it. And even when we do the join, they're not reading files, they're reading the code as well. Yeah.
Mm-hmm. No, exactly. And sometimes writing files takes like a while too. It's a very large raster or something.
Yeah, that's true. Yeah. Cool. I'm going to then bring Majid back up as well. And we can have some follow-up questions. I'm also just want to open it if there's anybody in the audience that has any questions. We can people can ask them. But otherwise, I want to sort of take a step back and ask a bit more about how you guys are using Fuse, the value that you're seeing. And so, Majid, previously we've had conversations in the past, and you've told us that using Fuse has helped you bridge this gap between the back-end processing, so like actually analyzing the data and then delivering it. Could you talk a little bit more about that, please?
Yes, absolutely. So as Emma mentioned, I guess in traditional GIS work, in terms of data science and engineering, you have to rely on multiple platforms to be able to build potentially insights for decision makers. And one typical example that she mentioned, yeah, we had to do the analysis in one platform, take it to another one for visualization, and bring it back. But we know that the size of these data are quite huge a lot of time, that still processing, ingesting them, you just saw in few seconds. Usually this will take hours in a lot of platforms to be able to even load the data and see them, let alone processing them. So you can imagine the impact of this kind of challenge in a broader, bigger products that rely on geospatial data and support. And the good thing with Fuse is that you have it all in one again. Uh, to me, bulk of the challenges we'll see, yes, we are seeing a lot of efforts on ingestion, processing, and visualizations, but still data stitching and bringing all into one unified data model that can answer different kind of questions is something that need, similar to a lot of data products development or software development initiatives, you need a lot of testing back and forth, see whether the model works fine, whether the results are working fine. And again, being outside of, I guess, a broader data pipeline that you have to visualize and process because of the challenge of the geospatial data, it's something that, to me, Fuse is doing a really, really good job on that. And I would say that I don't want to compare, I guess, platforms right now because you're seeing a good amount of, I guess, initiative, and I love to see when I see every, I guess, player makes a movement. But right now, based on a lot of traditional platforms, this is not a possibility, especially when you look at it in the broader picture of the product development. You can imagine, I mentioned the environmental and climate and sustainability, something that relies usually on analysis at the scale, not even like a US wise. Imagine the world, basically, you want to build a data model for the entire world to answer these kind of climate questions. And uh, right now, at least in geospatial industry, we see that kind of gaps to be able to use things in one platform and integrate it with others. So right now, what we have done in Fuse, it could be easily integrated in others as well. We can read into their notebooks, I guess, the Fuse kind of libraries and do the analysis and bring it all into one unified environment. That's, to me, the biggest value. I don't see any other similar example, to be honest, in the industry. Uh, but I know there are still a lot more challenges to tackle as well too. As yes, we solve this in geospatial industry. Down the road, there are going to be a lot more complications as well. I think this is the good example that can help us at least to simplify some of the processes down the road.
I want to talk a little bit about that a bit more. You guys were already interested in using hexagons when we started working together. And so, Emma, you talked a little bit about some of the values that you've done there. And I'm just curious about how you started using them and if there's ways in which Fuse has helped you with like adopting that and using it.
I can talk a little bit on that. First-hand experience, seeing hexagons, and Emma, feel free to share as well. We all know the power of visual analytics, especially in geospatial industry for non-technical audiences. That's something everyone gets excited because they understand geography, the concepts of it. But H3 uses that base geographical concept of the distance and try to normalize it. And to me, that normalization from visualization standpoint, uh, seen a lot of reactions from different non-technical stakeholders. Again, this is an advancement in terms of visualization. I can compare different regions because you normalize distance. That's the cognitive kind of concept that H3 is solving. But at the same time, if you look at it for a processing standpoint, it simplify a lot of analysis for the proximity, for all of those topological relationships are held within H3. So that's why you see a lot of different data sets in geospatial industry these past few years are all reported at H3. Telecommunication data is a really, really good example. For example, you look at the FCC national map in the US, publicly available. You go, you see all of the service availability, but all of the providers, telco companies are reported at H3. Huge, huge data set. There are reasons for that. So even public, non-technical people see the value, And due to some of these reportings at H3, we had to adjust to this as well too. And the challenge is that right now a lot of cloud technologies or warehousing technologies provide that as a native basically library, like Snowflake, Databricks, for example. But they are not, again, they're all lacking that limitations. All right, we have that visualization, we have the processing backend, but they're not part of one integrated environment. And that's the whole value. So I see the trend of moving towards that direction of H3 more and more, but still the lack of bringing it all together is just quite dominant in the industry, which again, Fuse is something that resolve all of those at once.
Does that mean that you can have like the same people and like the same team of people working on it, whereas before you might have had different team members? So like data engineering and maybe some front end people. Is that also something that you're seeing?
That's a trend. I would say there was always a challenge because at least in the GIS industry or remote sensing, we see the trend of a lot of software engineers and developers learned a lot more about geospatial and make the most advances into that. And that's how it's been done. If you look at the improvement in the GIS company like Esri, you see the improvement rate is way lower compared to the ones that coming from more software engineering backgrounds. So now we'll see they've been adopting these kind of technologies like H3 and so on. That's to me one of the reasons we'll see rapid advancement in the technology as well too. And they'll adopt this. That makes life potentially easier for a lot of decision makers to get to those insights faster as we have better technologies, more aligned with the trend in the industry. As we know for a fact that geospatial was always a little bit behind in terms of technology
Yeah.
compared to the broader industry, but now they're getting way closer as well too. And see the advantage all over, seeing a lot of rapid application development using geospatial data, and hopefully Gen AI will improve that as well quite soon, as I know Fuse are on top of that as well too.
Yeah, and
Yeah.
I'll just say, Fuse also, like, it gives me, like, someone like an analyst or developer the ability to maybe take more, like, it's easier to scale things up, which is something like, you know, if you're like used to just coding in notebooks, you're not as good at that. So you can dynamically like change your machines very easily, write out calls, use these UDFs to do that, and gives the data scientists more power to run some of this on their own too.
Yeah, I come from that same background, so I resonate with that. Yeah. I see we had a question in the chat from Talal. Can we build new layers based on the analysis outcomes, new polygons for commercial activities, for example? So I can answer that, but I don't know if Emma or Majid, you guys want to answer that as well? Like the ability to build on top of the UDFs that you already have.
Yeah, I mean, just like we saw in the demo, we kept layering the UDFs on. There's like really no reason, like you just use your Python languages, extract what you need, and just keep building it on and have all your building blocks. So definitely.
I think that sounds good then. Unless you guys have anything else that you'd want to add, I think we can wrap it up here. Thank you guys for your time.
I think there's another question.
Oh, sorry. How fast? Oh, yes. How fast are reasoning 35 data pipelines to see the results in the front end? Should we predefine early data partitions in the table? Who tail this responsibility of data partitioning and reclassification? I mean, the number of 35 is a specific number, but yeah, I mean, like we have here like 4 data sets in the demo that you're doing, Emma. There is some work in partitioning the data in the first place so that it's quick to access, and having it in hexagons helps. I think in the demo, Emma, you were showing going from the polygons to the hexagons. There's re-aggregating at a specific hex resolution. All of that is based on being able to have the data partition in a pretty smart way. But then it's enabled by having UDFs that are able to run in real time on top. Yeah. if there's any other questions, feel free to ask them.
I was just want to double down on the demo that we saw, because the first time that I saw it myself, it was quite eye-opening on how actually we've come from geospatial industry, from early days of developing app. I built Esri-based app using Arc Object like 15 years ago. For, I guess, more veterans in the industry, they might know a little bit about Arc Objects, all the way to the now that we are able to ingest this gigabytes, sometimes terabytes of data
Yeah.
quickly. It's quite eye-opening. But at the same time, you saw the live demo that within few seconds, yeah, processing was done, but visualization was updating as well too. To me, that helps a lot of data scientists, engineers to pressure test things quickly. And it's just one step closer that we see in the industry, especially with all of the AI and Gen AI advancement. The whole process from ingestion to the insights needs to be automated as much as possible. Get to the kind of information that we want as fast as possible, or a lot faster than current uh, industry trends. And I highly recommend a lot of people to test, explore these kind of platforms for the sake of the industry and our expertise. Definitely appreciate the Fuse team put all of these efforts to make this happen.
One thing I'll add here is that we at Fuse, like you were using the product, we're using Fused a lot, and one thing we've seen really change in the last couple of years is really the rise of LLMs and ChatGPT, Claude, and those are really good at coding. And so, Emma, you were talking about you like hexagons because you can then do SQL queries on them. I've never spent much time on SQL. My ability to do SQL is not very good, but I can ask ChatGPT or Claude or whichever one, like, hey, I want to do this aggregation or this join or whatever. And before that, I can, it can tell me the answer, but I need to actually execute it to verify, is this actually what I wanted, or did it give me the wrong answer? And one of the values we've seen is to be able to say, okay, let me put that in. Maybe I know that it got like an import wrong or something like that. And then we can iterate really quickly. And so because that execution still isn't there in a lot of these LLMs, being able to say, I'm going to ask it to bring in or join, for example, or whatever you want to do in SQL or in DuckDB, and then bringing it in and running it and executing. To your point, Majid, makes it like a lot faster to iterate and to get to the, okay, I got the results that I wanted. And it also means that me as a data scientist, I can spend much less time going and learning exactly how DuckDB or SQL works, because then I can go read what I need, but I can get a lot of help from a tool that knows how to write these queries and then verify them myself. We have another question here. Define table partition is doing today manually. Do you have another method to do it inside the SQL? I'm not sure how I would answer that. It is still like partitioning is depending on the problem that you have. It's a little bit like doing an analysis. It really depends on the problem that we want to solve. But when you have hexagons at a base resolution, you can then aggregate them at another resolution. You can still do a lot of processing. So having UDFs allows to take whatever data set we have already and then just work on it on the fly. I'm not sure if that fully answers the question. I'll encourage people who are interested to go check out Fuse. We'll have links. If someone on the team could put that in the comments here, that'd be great for people who are interested. And yeah, Emma, Majid, thank you both for your time. Thank you for the demo. Thank you for doing this Q&A with us.
Thank you for inviting us. It was a really good experience for ourselves and our team as well too. And looking forward to learn more about the advances in Fuse and how you are making a change in the industry.
Yeah, thank you very much. I learned a bunch about grapes and agriculture and irrigation that I didn't know about. So thanks for that as well. All right. Thank you very much.
Cool. Thank you.